Hi, and in today's video we are going to be looking at drawing graphs and specific looking at those kind of graph questions you get in science. We're looking at a chemistry example here. So this is what you would be given in a test. I've taken this straight from an exam paper that's previously shown to me before, and it says the table below shows the students' results, and it's got time in seconds going in 10-second increments, so it's going up in 10 seconds at a time, and then you've got your mass of gas on the right hand side produced in grams. And then the question says plot the data from the table above on figure 2 and draw a line of best fit, and you're going to get 3 marks for that, or that's the maximum you can get. So we're going to get 3 marks, that's the plan. So the first thing's done for you, the hardest bit that I always find students struggle with, drawing the axes and putting increments up, so you have to obviously make sure it goes up in a certain amount each time. That's already done for you. So what you have to do is plot the data and draw a line of best fit for these 3 marks in this question. So the first one is a time of 0 seconds, has no gas produced, because before the reaction starts there's no gas produced. So what you have to do is go down to here, 0, 0, and put a cross. So if I just put a cross there, and then if we go up 10 seconds, 0.8 grams. So I'm going to go down to 10. So 10 seconds is 0.8. And you need to work out what's in between these things. So in between 0.5 and 1, there are 10 spaces. So that means that each of these, each 2 squares is 0.1. So every 2 squares is worth 0.1 in between. So this would be 0.6, and then if we zoom in we'll see it better. And then 2 squares up, 0.7, 2 squares up again, 0.8, quite a thick pen. 2 squares up again is 0.9, and then 10, and then 1. So as you're going up, we're going every 2 squares is worth 0.1. So every actual square is 0.05. That's half of 1. So it said 10, 0.8. So you're going to go 10 up to 0.8 and put a cross there. Then we're going to go up, and it's 20 and 0.6. So you're going to go along from 0.6, because that was 2 above the 0.5. And you're going to put a cross there. Then it's 30 and 1.6 grams, so 30 and 1.6 grams. Now remember, every square is worth 0.05, so every 2 squares is worth 0.1, so this would be 1.6. So I can go along up from 30 up to that 1.6 there and put a cross. Next one is 1.8, so you'd go to 40 and then you'd go up to 1.8. I'm going to have to scroll out so I can see this. So it's 1.8 and 40. So you're going to go up from 40, and it's going to be, that would be 1.7 because it's 2 squares above 1.6, and that would be 1.8. So I'm going to go along till I'm above 40 and in line with that 1.8 grams and put a cross. And then 50 is 2, so that's nice and easy because that one's there. So you go up from 50 all the way until you're in line with both 50 and then in line with the 2. And that final one, 60, up and a 2 there. Now, the line of best fit is the next bit that we need to look at. And people often struggle with line of best fit because in maths often we're told to make sure it always goes through the origin, and this one is going to, but they don't always go through the origin. So don't worry about it passing through this point here, where this cross is. It does not have to pass through that point there. It can, and it will this time, I think, but don't worry if it doesn't. Now, I'm going to have to try and fit through the pattern that most of my little data points, these crosses, go through. Now, this one here, I'm going to circle. And I'm going to circle that for a reason, because that is an anomaly. It doesn't fit the rest of the pattern. The rest of it, as time goes on, the amount of gas produced increases. This one seems to be an anomaly, which means it doesn't fit the pattern, and we're going to leave that one out when we draw the line of best fit. So with the rest of these, I'm going to draw a curve, because our line of best fit can either be a line that's a curve or a straight line used with a ruler. And with the curve, best thing to do is try and do it in one sweeping motion rather than using lots of little lines to join up the dots. So you should never, I'm going to show you what you should never do this. Dot, dot, line to dot, line to dot, line to dot. That's not a line of best fit. We just join the dots there. What you should do is one motion that goes through as many of those as you can. So I'm just going to do, and that's a curve of best fit there. It might have been that actually if the points were not a curve, that you would have had to draw it with a ruler and a straight line and have gone through as many points as possible, leaving out those anomalies or ones that don't quite fit the same pattern as the rest of them.